Okay, so at the end of last lecture, I got a little bit lost and confused rearranging and trying to solve simultaneous equations. So I'm just going to go through the example that we tried to go through in the lecture, giving you a kind of a worked example of how we go about solving these types of equations, so these kinds of problems. Okay, so we've got here the basically the last slide of the lecture with the three sets of simultaneous equations. So in each case, we've got two equations, one equation and another equation. Both of the equations have two unknowns, so they both have an x and a y that we don't know. So because we have two equations and two unknowns, that kind of suggests that we should be able to solve those. So in the lecture, we kind of like gave you some answers. Okay, so we've got basically a target to aim for now. We need to find out how we go from this to these answers over here. Okay, so we're going to go through that, just this first worked example, and then you can kind of do the other two in your own. Okay, so first of all, these are the two equations, equation 1 and equation 2. And the first thing I'm going to do is I'm going to rearrange those equations, okay, to make y the subject of those equations in both cases. Okay, so in the case of the first equation here, you've still got to remember when you're rearranging equations, you're just doing the same thing to both sides of the equation. So the first kind of move is to kind of isolate the y's on one side of the equation. So I've basically taken away 3x from both sides of the equation, so that just becomes 3x minus 3x is nothing. So it becomes 2y equals 5 minus 3x on both sides there. Okay, and then to get just y on its own, okay, I'm dividing both sides of this equation by minus 2. So minus 2 divided by minus 2y divided by minus 2 is just y. Okay, and then this side of the equation divided by minus 2 is this thing over here. Okay, so that gives us an equation that's y equals something. Okay, and I can kind of like expand out this fraction here to give us something that is y equals, in this case, 3 over 2x. So minus 3 divided by minus 2 is 3 over 2x. And 5 divided by minus 2 is minus 5 halves. 5 over 2. Okay, so this gives us an equation like this. You can do exactly the same thing with the second equation. It gives us another equation that's y equals, and then on this side of the equation we've got x times something, and then plus, or in this case minus, a constant. Okay, so this we can basically rearrange in terms of into linear equations. So y equals 3 halves x minus 5 over 2, and another equation y equals minus 2x plus 9 over 2. Okay, so we can sketch out those linear equations. So there's one, there's the other. Okay, so you've got the intercepts are the constants here, intercepts with the y-axis, and the gradients of those lines are these constants that are times by the x. Okay, so you can see that these two lines cross at this point here. Okay, so to solve these two simultaneous equations, what we're actually doing is we're basically looking for that point where these things cross over. Okay, so I'm just going to go through two approaches, two ways that we can go about these equations. Okay, so one thing we could do, okay, is we could substitute one equation into another. Okay, so here are our first equations at the top that we started with, and we've rearranged both of those to equal y. Okay, so we can take this value of, or this new equation for y up here, and we can insert that into the other equation, okay, that we started with up here. So we can substitute 2a into 1. We could in fact substitute the answer to 1a into 2. Doesn't really matter which way we do this, okay. But if we do this for the 2a into 1, we've got 3x minus 2y, and in this case we're basically substituting in the equation for y. Okay, so this is this into here, okay, and equal to 5. Okay, So now we've got one equation that only has x's in it. Okay, so what I'm going to do now is I'm going to multiply out these brackets to try and solve this equation to just get one x on one side and then a whole bunch of numbers on the other side. So first of all, so 2 minus 2 times 9 over 2 is minus 18 over 2, and minus 2 times minus 2x is plus 4x. Okay, so this 18 over 2, that's equal to 9. So we can basically take 9, or sorry, we can add 9 to both sides. So minus 9 plus 9 is 0, so that means this term disappears, but we have to add that 9 over onto the side. Okay, and we've got, that leaves us with 3x plus 4x equals 5 plus 9, which is equal to 14. Okay, 3x plus 4x is just 7x, so 7x equals 14. So we know that x is, if we just divide both sides by 7, 7x divided by 7 is just x, and 14 divided by 7 is equal to 2. That gives us x equal to 2. Okay, so that's the substitution method. That gives us one of the variables, x. And what we're going to go through now is just basically the kind of, I could say, the equivalence method. So when we first rearranged these equations up here, we ended up with two equations for y. Okay, so we've got one expression that will equal y and another expression that will equal y. Okay, and we know that y is equal to y, so it must be equal to itself. So we could say that this term equals this term. So we could rewrite that down here. So 3 halves times x minus 5 over 2 is equal to 9 over 2 minus 2x. Okay, and then all we need to do is rearrange this equation, okay, to get an x on one side and then some numbers on the other side, and that will give us the value for x. Okay, so all we're doing here is, first of all, I'm adding 5 over 2 to both sides, and that makes this disappear and puts 5 over 2 on this side of the equation here. And then I'm adding 2x to both sides. Okay, so minus 2x plus 2x disappears, and we put a 2x over here. So on this side we've got 3 over 2 plus 2x equals 9 over 2 plus 5 over 2. Okay, and we can rewrite that 2x as 4 over 2x, so 4 halves is equal to 2. Okay, and that basically gives us the same terms on the bottom of all of the equations here, or all of the parts of the equation, so we can just times both sides by 2. That's a little trick there, which will give us an equation that's 3x plus 4x equals 7x, okay, and 9 plus 5 equals 14. So again, we've got x is 14 over 7 is equal to 2. Okay, so both methods where the kind of the substitution and the equivalence method have given us a value for x, and then we actually have equations that relate y to x. Okay, so if we know x, we can then work out y. Okay, so we can substitute that into those equations. In this case, I say y equals 3 over 2 times x, so 3 over 2 times x up here, 3 over 2 times the value of x here, which is 2, minus 5 over 2. Okay, and you can just work that through. So 3 over 2 times 2 is basically 6 over 2, minus 5 over 2, so 6 halves minus 5 halves is 1 half. Okay, and you could have done that with the other equation and you should have got the same answer. So now we've got a value for x and a value for y. Okay, so the thing to do now is just to check your answer. So take the other equation that you started with, okay, so in this case 4x plus 2y equals 9, and just plug in the values that you have calculated. So 4 times 2, because 2 is the value of x, plus 2 times a half, okay, that's equal to 8 plus 1, which is equal to 9, okay, and that is the value of the kind of we were looking for. So that we've checked that we've got the right answer. Okay, going back to the graph, we can see if that's reasonable as well. So we've got our two equations, our two lines intersecting, okay, and they're intersecting in this quadrant here, so they're telling us that we probably should have a positive number for x and a positive number for y, and that's what we've got. 2 and 9 are both positive, 2 and 9, 2 and a half, sorry. So x equals 2, y equals a half, they're both positive numbers, and we can see that we kind of like, we go along kind of 2 for only going up a half, so along to upper half. I mean, this is only a sketch graph, so you can only really take this test so far, but we can see that we're getting a reasonable result. Okay, so hopefully this should help with the other examples, which I recommend that you go through. But as a summary, basically rearrange the equation to make y, or to make one of the variables the subject of both of them. Draw some graphs to see where they should intersect, and then either substitute in the value of the variable that you've rearranged for into the initial equations, or you can use the equivalence method and say one equation is equal to the other equation, so 1a equal to 2a in this case, and then rearrange the equation to isolate the other variable, in this case x, and that will give you hopefully the right answer. And then once you know the value of one of the variables, you can then plug that into either of your starting equations, okay, to find the other one. Okay, so have fun with that maths.